All right, so the rest of the definition in 1.1 is posted as well. So I'm going to leave that to you guys right now. I'm going to head into 2.1. Just so that I can make sure that everything is taken care of. Actually, I'm going to say 2.1/2.2, and I'm going to call it organizing data. So I'm going to take, for example, to start off with just is a slew of data here. So let's say I have these data points. I have 7, 6, 6, 6, 4, 6, 2, 6, 5, 6, 6, 11, 4, 5, 7, 5, 2, 7, 1, 2, 4, 8, 2, 6, 6, 5, 5, 3, 7, 5, 4, 6. Wow. And last line, 2, 2, 9, 7, 5, 9, 8, and 5. So, number one, how many data points are there? 40. Because what you can see is that I have 2, 4, 6, 8, 2, 4, and 5 here. So 5 times 8 is 40 because everything is filled here and here. So I can actually figure out that is 40 data points. Okay. So the first things first, let's talk about what the definition for frequency distribution. It's a list of each category of data and the number of occurrences. Oops. Of each category. So there's a couple ways I can deal with this. Ooh, why did I do that? Hold on. You're fine. You guys can stay exactly where you guys are at. I'm just going to do this. So a couple of things I could do, right? I could set this up so that this is, so as I look at the data, I can see that everything's going from 1 to 11. Is that right? So what I can do is go, okay, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can do that. Right? I can do that. But I can also do these in classes as well, meaning there's more than one number in it, right? I could make it as 1 to 3, and then 4 to 6, right? And then 7 to 9, and so on, which would give me a little bit less class, or yeah, less class. Okay. But let's say I'm going to do it this way, right? So my next column is going to be frequency. But here's the thing, when I do the frequency, I'm going to probably do this with tally marks instead, rather than like taking 7 and counting number of 7s in there. Does that make sense? So I will probably do it this way, going, okay, the first one is 7. I'm going to put a tally mark at 7. 6, 6, 6, 6, 6, 6, 4, 4, 6, 6, 2, 2, 6, 6, 5, 5, 6, 6, 6, 11, 11, 4, 4, 5, 5, 7, 7, 5, 5, 2, 2, 7, 7, 1, 1, 2, 2, 4, 4, 8, 8, 2, 2, 6, 6, 6, 6, 5, 5, 5, 5, 3, 3, 7, 7, 5, 4, 4, 6, 6, 2, 2, 2, 2, 9, 9, 7, 7, 5, 5, 9, 9, 8, 8, 5, 5. That seemed like a lot of work. We're okay there? So then I can obviously add up the tally marks and saying, okay, I got 1, 6, 1, 4, 8, 10, 5, 2, 2, 0, 1. So this would be my frequency distribution. And that's how I would do it. Now, would it be a good idea for me to add all these numbers up together to figure out if it adds up to 40? To make sure I got everything? Probably a good idea, because chances are I'll be doing this, right? And my phone vibrates, and I look at the phone and I forgot where I left off, or if I put that tally mark down, right? So let's add them up. 1 plus 6 plus 1. We're stuck. That's 8. Plus 4 is 12. Plus 8 is 20. Right? Plus 10 more is 30. And then 5, 2, 2, 1 would give me the other 10. So 40. So yes, I have a total of 40. Actually. So yes, that checks out. Perfect. Okay, so the next definition, it is the relative frequency. The proportion. Oh boy. Or percent of observations. Ooh, yeah. Within a category. So I do not like this formula whatsoever. So it's a frequency divided by sum of all frequencies. Okay. Here's the thing. We just summed up all the frequencies, right? What is that really? Sample size or the number of observations, right? Right. So I almost want to call this number of observations. Okay. So when we do relative frequency, we actually have to do it for each individual one. So when we do relative frequency, no problem. Just change your don't forget to change your name. That's all. So for example, in this case, this relative frequency is going to be what? The frequency divided by the total, which is 1 divided by 40, which is equal to. Oh, did I have to do the math myself? Sorry, my bad. Don't worry, guys. I'll do it. I'll get the calculation. I got you. 1 divided by 40. Very difficult. Sorry. 0.025. And now I gotta find this, right? You guys want to finish the rest of these up for me? Or you're like, you're on your own, dude. I don't really care. Here, I'll do the 10. So 5 will be 0.125. 1 is 0.025. So that means the two must be what? 0.050. So 4 must be 0.100. So 8 must be 0.200. How did I do? Wow, no calculator needed. Look, Ma, no hands. So when you add all these frequencies together, what should you get? Only if you multiply it by 40 when you get to 40. But yes, you should get 1. If you add all the decimals together, you should get 1. This would make things interesting. Can I? That doesn't help me. That won't help me either. Okay, I'm just gonna have to do my due diligence. Are we okay here, guys, so far? Now, I could make a bar graph off of this, but also the other thing is that I want you guys to understand that I could have made this graph, I mean, this chart a little bit differently too, right? I could have made this chart where the categories were more like classes, right? So I could have used something like 1 to 3, right? The part that you have to understand if I do classes, that this width has to be the same. So if this is going to cover 1, 2, and 3, that means the next one has to cover 4, 5, and 6. And then 7, 8, and 9. And then 10, 11, and 12. Right? So this would cut down the number of categories there might be. But you guys got to be careful because sometimes they will tell you that, right? But I don't want it so that only one thing or no thing in order for me to get that last category. So they might tell you, they might give you this info and say, okay, we want to break this down to, let's say, 5 classes or 5 categories, right? Then you guys got to figure out what that width would be in order for that to happen, because like this right now is only 4, right? Or they might say 3. So now you got to figure it out and go from there, right? Which, if you think about it, if I have, well, no, that won't work. If I was to, let's say I was taking the ages of every single student in my class, right? And let's say that the age range from anywhere from 20 to 40. Oh, shoot, every single time. Sorry, guys. So let's say that the ages ranges from 20 to 40, right? So, or I should say 21 to 40, or 18 to 38. Sure. And it wants you to make it into 5 categories, right? So how many ages would be in each category? So from 18 to 38 would be 20, right? And if it wants 5 classes, then it means that I would have to have 4 ages in each class, right? Does that make sense? Because you took the 20 and divided by the 5 classes to get that 4. So you got to make sure that when you go, that you include those 4 age groups into that class. Okay. So just be careful that anytime you're going to use something like this, that class width has to be the same. All right. Now I can graph this too. So let me go ahead and erase this part and graph what I want to graph. I just want to show you that part. So let's say I graph this. And the frequency went from what, 1 through 10? One 16148. Oh, come on. You really did that, didn't you? I'm gonna have to let you guys class early. 16148 10522. That won't help either. That won't help either. Okay, so I'm gonna have to do it this way, won't I? Yeah. I'm gonna have to change this to this, change this to this, right? Okay, so that's Mike. So I'm gonna undo this. My iPad's going into survival mode here. I guess the school is just gonna have to buy me a second iPad. I think that's the only appropriate thing. Right, so this would be for my tally marks, obviously, and obviously these things look weird right now. That looks better. Or purely just gonna leave, one or the other, right? So I can do this for not just a frequency, but I can also do it for the relative frequency. All right, so I could do it for the frequency. But I could also do it with the relative frequency. And if I look at the relative frequency, that's going from what? The highest is 0.25. Let me do this. Right, so I'm just changing the y axis to decimals. So what do I have here? 0.025. Did I get lucky? I did not. Oh, I did. I did get lucky. I got very lucky. Do you guys see what just happened? They just happened to be the same. Okay. So now there's going to be times that they're going to ask you to do it this way. What is it called? Where are you? You're supposed to be right here. No. No. Why is it not showing me? Not that. Not that. Oh, there it is. I believe this is pronounced Pareto. I have no idea. Pareto. Bars are drawn in decreasing order of frequency or relative frequency. So essentially, you're just picking up the category and just moving them. So it's going from greatest to least. Does that make sense? Yes, I hope. Are we sure? Yes. Do I need to make him? Just a burn of time. That's only the problem. So you guys might see side-to-side bar graphs. Side by side. So when do you think you would see a side-by-side bar graphs? I'll call them categories, right? So it could be like one of them that they like to compare would be like, hey, look at the graduation rates today versus 10 years ago, right? So because technology is coming in, what's happening with that? Or look, the graduation rate before the pandemic and the graduation rate during the pandemic didn't change any, right? They want to try to compare those two to see what has happened and what has gone on and so on and so forth. Now, a lot of times these charts here is also could be done vertically versus horizontally, right? You guys seen horizontal slopes, horizontal bar graphs just like these ones, but have you also seen vertical ones? So, for example, if I had a vertical bar graph, so let's say, for example, we're talking about, let me do this. So let's say we're doing a side-by-side bar graph, and we're comparing the graduation rates in 1970 versus 2020. Okay, so let's say if that's the case, then on a vertical bar graph, we're going to say why is it 80? Why isn't it 60? Right? So let's say that I have that, right? That would be the so-called vertical versus the horizontal would look something like this. right? So what's the difference between those two? Sorry, guys. I got these two switched. Yeah. Yeah. So the bars are horizontal rather than vertical. So if you notice that here, what people think is important information would be the years, right? Is it the 1970 or is it 2020? Where here is a little bit harder to read because that important information for them is that they have to read it sideways, where here is pretty straightforward, right? Is the percentages, which is a lot smaller of a piece of information that they might not need to read it sideways, right? Because sometimes this category here might be longer than just 4 digits. Does that make sense? Where now I can read it straightforward, where over here, when I put it sideways, now it might be long as well. So it's harder to read. Are we okay there? So next thing would be pie charts. So let me ask you guys this. So here I have a pie chart. So let's say I go back to my data here, right? If I was to represent the 1, 3, 11 in a pie chart, how would I go about doing that? How would I know what sliver of the pie would represent 1 versus 10? Ooh, relative frequency with, I agree with you, because the relative frequency is talking about percentages, right? So it's a percent out of 100%. So how would that help me with a circle? Think about this. You have it. It's absolutely right. So if I was to take this, look at this. How far have I traveled? Because I know here I have 25%, also known as 90 degrees. I have 50%, known as 180 degrees. Come on. 50% is 180 degrees. Come on, Roberto. Right? If you took the relative frequency and all the way around the circle is 360 degrees, right? So for example, let me see. 6 was 10, right? So if I took the if I look for the angle for number 10, for 6, that will be the relative frequency of 0.25 times 360 degrees, and that's going to give me 90 degrees. So therefore I know that this would categorize for 6. Because that represents 10 out of the 40 people. Right? Does that make sense? So you would do exactly the same thing for the other categories to get the rest, right? So that means the 5 must mean it's going to be 45 degrees. The 4 would be 36 degrees. Okay, good talk. I'll move on now. You guys are killing. Yes. This thing right here. This just means angle. So I'm looking for the angle for 6. So the angle here would be this piece right here. Right? And that would be my so-called 90 degrees. Okay. Yeah, so yeah, that symbol just means angle. The measure of the angle. Okay. What's the difference between a bar graph and a histogram? Okay now? So classes are categories where the data are grouped. In a class, you might have a lower class limit I shouldn't say in the class, I should say in a class. You have an upper class limit. Gee, I wonder what that's going to be. Does any of this make sense so far? So remember the categories I was making for the data that we wrote down, right? I said 1 to 3, right? 4 to 6, and so on. So if it was 4 to 6, then the lower class, so 4 to 6 is a class. The lower class limit would have been 4, the upper class limit would have been the 6. Right, which is different for each class because the next one is 7 to 9. So the lower class limit is 7, the upper class limit is 9. Make sense? Which is in a different class. Now, this is weird to me, but it is what it is. Because, where is it? I don't like this definition, but obviously I still gotta give it to you. It's called a class width. The class width, it says, is the difference between consecutive lower class limits. So when I had 4 to 6, 7 through 9, then it is a 7 minus the 4. Right? It's a because 4 to 6, the lower is a 4, 7 to 9, the lower was a 7. So it's a difference between the 7 and the 4, which would give you 3. So why do I think it's weird? Because they then continue on to give you a formula for class width. Which is the largest data value minus the smallest data value divided by the number of classes. Which I already talked about, right? If the age span was like 20, right? 38 minus 18 is 20, right? And if I wanted 5 classes, then I would divide that by 5 and know that it's 4. And then you hang up. The last thing I want to talk about is dot plots. I'm going to give you the definition of dot plots here. Actually, I'm not even. Yeah, so I want to give you this definition. Okay, let's just give it to you. Drawn by placing each observation horizontally in increasing order and placing a dot above the observation each time it is observed. What does that sound like? Huh? The frequency chart. It actually sounds like a tally, right? The tally marks. But instead of tally marks, you're doing dots. So if I was to do it for this, it literally would look something like this. Here, let me go ahead and bring this. Copy. Paste. Let me find a good corner there. Okay. So let's go ahead and create some fancy dots here. So hey, hey, hey. Because that's essentially what it is. Right? So now I can go, okay, take this, get rid of this, and go, okay, this needs 1. Hey, get back there. This needs 4. This needs them all. And 2 more. You go back to where you're supposed to be. Why is nobody copying this down? Can't do this on your iPad? I don't understand. Oops, too many. Fine, you go over here. Hey, dot plot. Now, notice how it says placing each observation, right? Horizontally. So I do not believe this is saying that I can put these in classes. Does that make sense? Because it says drawn by placing each observation horizontally. So that means I got to put individual numbers down. I can't put a class down and have that as an observation. Does that make sense? So by the sounds of this definition, it sounds like it's going to be individual. But it does look pretty. I don't know what the purpose of it is for. I'd rather just do tally marks. Why can't there be a tally plot? Wouldn't that be nicer? Just a tally plot. And then, oh, that's what I gotta say. All right, so when you guys do histograms and, well, mostly histograms, what's going to happen is a couple of things going to happen. Because histogram is just a graph come on. And what's going to happen is that you're going to start to see certain shapes. If you start to see that all the bars are exactly the same height, this is considered a uniform distribution. If you see that everything is kind of even, right, where it looks like someone's flipping you off, then this is called a bell shaped distribution. And down the road, you're going to find that this is going to be called normal as well distribution. If you see that more people are getting A's, right? This is called skewed right. I know it doesn't seem right, because to me, in the English language, to me, this would tell me to skew left, right? That everything kind of pushed to the higher grades. But no, this is called skewed right. And this right here would be called skewed left. And you'll be learning you'll be practicing on how to, not how to, but you'll be practicing on identifying the different distributions. Any questions? Yes, you guys received more definitions today, right? But you also got a chance to kind of see what some of the things are going to be like as you're going to go. Now, since I'm not going to be doing a project, right? Like, I'm not going to have you guys do any group projects. This pie chart thing is a kind of a big deal, right? Actually, when I did statistics in college, I actually didn't have the guidance of the professor to help me when I did a project of a pie chart of how to go about doing it. It's kind of like something that you kind of need to figure out as you go. So and here's the thing, I don't know how I would grade you on a lab work when it comes to a pie chart, right? Am I going to get my protractor out and measure and make sure that you have that angle right? Right? So the pie chart is important, but at the same time, maybe what I need to do on the exam is to just talk about what that angle would be. But so the biggest part is that because you have the relative frequency, that makes it easy. The only thing you have to remember is how many degrees is in a circle. That's all you have to remember, and you have it. Okay. But other than that, I guess I'm letting you guys off the hook early. Unless you guys have more questions for me. Lab work, MLM. Well, if you guys have other questions, please feel free to stay after and we'll talk. Other than that, ladies and gentlemen, please have a wonderful, blessed weekend. Love you guys. I'll see you guys next Tuesday. Later. Bye.